Hello, let's do checkpoint 6.39. They want us to calculate the line integral over a closed curve. The symbol partial d here refers to the boundary of d, where d is the annulus given by the polar inequalities. R goes from 2 to 5, and theta goes from 0 to 2 pi. So, not drawn a scale, we have our inner circle radius 2 and outer circle radius 5, and the region D is that space in between. All right, we will invoke Green's theorem, which says that the line integral of the closed curve C, or in this case the boundary of D, of f dotted with dr will actually equal to the double integral of D itself, and it's going to be the partial of q with respect to x minus the partial of p with respect to y dA. All right, I think we're pretty much set that we will be using polar coordinates with the given inequalities, so we just need to find those partial derivatives. The partial of q with respect to x is this one over here, and it looks like it's just going to be a 5. Partial of p with respect to y looks like there's no y's in there, so that's going to be 0. So that makes for a fairly simple integral. This is going to be a double integral over the region D of 5 times dA. Now we could take advantage of our fact that we have a constant times the double integral of d dA, and just find the area of this annulus, which is going to be the difference of the areas of two circles. Or we can set this up like a double integral. In either case, we should work it out the same way. If we were going to set this up as a double integral, this would be 5 times the integral from 0 to 2 pi with respect to theta, integral from 2 to 5 with respect to r, and the integrand is just going to be 1, and then your dA will include an extra r, dr d theta. All right, so this is 5, and this is going to be the integral from 0 to 2 pi of d theta, which is going to be 2 pi, and this is going to be the integral of r dr from 2 to 5. So that's just going to be a pi over, or r squared over 2. So we have 5, 2 pi, and this is going to be 1/2 r squared from 0 to, from 2 to 5. And let's start combining. We have 5 pi, and then this is going to be 25 minus 4, which is going to be 21. And we're going to have 21 times 5. I think that's a 105. 105 pi. All right, let's double check using the areas if this works the way it's supposed to work. The area, so it's area of the circle radius 5 minus the area of circle radius 2, and so pi r squared would be 25 pi minus pi r squared radius 2, so that's 4 pi, and this whole thing was multiplied by 5, so let's multiply that by 5 and we'll get the same result. 105 pi. All right, I hope that helps.